solving systems of equations. And you've done solving systems of equations last year. We reviewed it yesterday. The difference now is that these three systems that I asked you to look at are linear quadratic systems, which means one linear function, one quadratic. And you have to find the solutions. The good news is it's exactly like doing it in a linear system. There's very little difference. The only difference is you now are going to be needing to solve a quadratic equation. But you already can solve a quadratic equation. And when you first learned systems of equations, you couldn't, and that's really the only reason not to have them to get done as one unit. So this first one, y equals 4x plus 3, y equals 2x squared plus 8x plus 3. It looks like this. Is that right? Yeah, that looks like it. Are those the answers that you got? 0, 3, and -2, -5. Now, some of you are asking before, do we need to write our answer as an ordered pair? And when it's a linear system, you really don't, because you have one value for x and one value for y. But what you need to be careful of when you're stating answers for these ones is that the x value of 0 goes with the y value of 3. Somehow you have to show that those are together, and I would suggest doing it with an ordered pair, because you couldn't say x equals 0 and y equals -5. That's not the solution. It's a solution for x and it's a solution for y, but they don't go together. So I would suggest giving your answers here as ordered pairs. And most often you're going to have something like this, where you have two solutions. Let's look at the next one. Y equals x squared and y equals 2x minus 1. This one has only one solution. It's at 1, 1. So x equals 1, y equals 1. Sometimes you'll have only one solution.
It's a weird decimal, so it's okay if we just round it.
Yeah, your calculators, I don't know why it doesn't work. It is an exact solution, and if you solve it algebraically, it should be 1, 1 exactly. But the calculators give you, most of your calculators probably either gave you 0.999992 or something, or 1.000002. Something like that. And so if you get something like that, just round it. Oh, did you? And then sometimes they give it to you in scientific notation, right? It's going to say like 3.1245887 E negative something. Yep. And that means 0. And it should be an exact value of 0, so it's actually something that really bugs me. But we looked at two different things here. A linear quadratic system that had two solutions and one that had one solution. If you have something like this and you're solving graphically and you think it only has one solution, make sure that you zoom in on that point and make sure that it actually is only one solution. Because sometimes it looks like, remember we had that before where it looked like one, excuse me, x-intercept, but it was actually 2. And here's the third one. How many solutions does this one have? None. So you just write no solution for your answer. Are there any other possibilities for number of solutions? Infinite number of solutions? Yeah. So not for this. Not when it was linear, we had that possibility of an infinite number of solutions, but linear quadratic, we don't, right? Because they're two different shapes, so they're not going to have an infinite number of solutions. So I think they're only going to be 2 or 1 or none. Could there ever be 3 solutions with a linear quadratic system? No. No, there couldn't. All right, and then we have these quadratic systems. This is what you're asking about, right? Quadratic systems. Why don't you graphically solve these ones? The first one should look like, not that, this I think, looks like that. 2 solutions. 2, 6, and -1, 3 are the 2 solutions. you could have two solutions when you have one function opening up and one opening down. Or you could have it when they're both opening up or both opening down. I want you to think about what those might look like. But you could have two solutions.
Alright, what's the...
Did you get it? Okay, the second one, I believe, was this one. So this one has no solutions. And you could have that, again, if they're, this one, they're both opening up, but you could have it if one was opening up and one down, or if they were both opening down. And the third one, one solution at 0, 4. Are there any other possibilities for this one? So we had two solutions, one, and none. Yes, this one could have an infinite number of solutions, right? Because they're both quadratic. But I think it's always going to have one of those options. So this one has 4 options. 2 solutions, 1 solution, no solutions, or an infinite number of solutions. Now we're going to look at solving algebraically. And we're going to use elimination for this one. It's more complicated than the linear systems you were doing, but you'll see as we go through it, the steps are the same. We still do exactly the same thing. So there are 2 things that are a little bit different with elimination when it's a quadratic system like this or a linear quadratic system. One of them is that you may need to solve a quadratic equation eventually, whereas with the linear systems you only have to solve linear equations. The other difference is we have to be a little more careful about what we decide to eliminate. So when you look at this one, you know, you could choose to eliminate the x's or the y's, but in particular here we have to eliminate the y's. Do you know why? Because there's 2 different kinds of x's, right? There's x squareds and there's x's. And if we eliminate the x squareds, then we still have y's and x's and we can't solve. If we eliminate the x's, then we still have y's and x squareds and we can't solve. And so what we're going to eliminate is the y's, and we'll do that by multiplying the first equation by 4 or negative 4. I think I'll do negative 4. So when we do that, I get 16x squared plus 4y plus 8x equals 20. And the other one, I'm going to keep it the same, except I'm going to move that negative 37 over and make it positive on the other side. Because when you're doing elimination, it's easiest if things are lined up properly. So x squareds under x squareds, y's under y's, x's under x's, and so on. And then add them together. So when we add 19x squared, the y's cancel out. Negative, what's that, 38x equals 57. It probably would have made more sense if I moved the 20 over instead of moving the 37 over, because now I still just need to move it. But let's move that over, so we'll make it minus 57 equals 0. How do I solve that? Factor, right. To factor it, take out a common factor if you can. That should always be your first step when you're factoring. So this becomes 19, and then in brackets x squared minus 2x minus 3. 19 times 3, 57, equals 0. Now that's easy to factor, right? The x squared minus 2x minus 3. This is going to be x minus 3 and x plus 1. Which tells us that x equals 3 and x equals negative 1. But we're not done yet, right? Because we still need to find y. We have to plug both of them in, yeah? Because we're gonna have two solutions, right? Two ordered pairs, which means 4 numbers. So we have to find a y value to pair with each of those x values. So I'll take the first equation and I'm just gonna change it a little bit. I'll isolate the y to make it easier for me. We'll use y equals negative 4x squared minus 2x plus 5. Right? Move the 5 over to make it positive, move the y over to make it positive. And now I can fill those in. Y equals negative 4 times 3 squared minus 2 times 3 plus 5. So what does y equal? Y equals negative 37. So this is where it makes sense to write your answer as an ordered pair, so that we know that the x and y that are paired together are 3 and negative 37. And then we'll do the other one, the negative 1. So y equals negative 4 times negative 1 squared minus 2 times negative 1 plus 5. Y equals 3, and our other answer is negative 1, 3, the x value and then the y value. So these are the two solutions. Those are the 2 points where those graphs would intersect. So we're going to solve this by substitution. We need to isolate one of the variables in one of the equations. I am going to isolate the y in the second equation. Is that what you would do? Maybe. Y equals 2x minus 2. So just add 2x to both sides. And then substitute that into the other one. So we'll have x squared minus 2x minus 2 minus 2x equals negative 2. That's a lot of 2's. This was a question that came up yesterday about that negative y. If I'm substituting two terms in for y, so 2x minus 2, that negative applies to both of them, right? So this becomes x squared minus 2x plus 2 minus 2x. And I'm going to move that negative 2 over to make that also plus 2 equals 0. Because this is quadratic, I want it to equal 0 to be able to solve it. So when I combine all the terms, I get x squared minus 4x plus 4 equals 0. And then I can factor. X minus 2 and x minus 2. So from this we can say x equals 2. This only has one solution. We can find the y value from up here. And we'll go y equals 2 times 2 minus 2. And y equals 2. This had a crazy amount of 2's. But your ordered pair, your solution is 2, 2. There it is.